I want to use this Arduino Uno to do some data logging around my house. But with only 2K of RAM memory, I'm afraid I'm going to run out of space and lose some data. What to do? Well, maybe with the help of this chip, we can solve our problem. So let's find out today on this episode of The newer versions of the Arduino Uno use an Atmel ATmega328P 8-bit microcontroller. Well, this microcontroller contains 2 kilobytes of RAM memory that is shared for program variables as well as data that you record for your application. So it's a precious resource and you can run out of information or space to put your information very quickly. So we can solve this situation by adding an additional RAM chip such as the one that's shown to my right on the Vilros board. It is an 8-pin Microchip 23LC1024 memory chip that has a 128 kilobyte capacity and communicates with the Arduino Uno via the serial peripheral interface. The second half of the solution for today's problem is a software program, an example of which you can see behind me, that will communicate to the RAM chip whenever we need to either read or write data from our program. So first we will discuss how the hardware is wired, then we will discuss the software program, and at the end of that we'll see an example of how the program works. So let's get started. So let's talk about the hardware that we're going to use in this solution for our problem. To my right, you can see on the Vilros board there is a RAM chip that's soldered on an Arduino Proto Shield that is mounted on an Arduino Uno board. You can look at it and see the placement of the components and how it's wired and how it's connected to the headers connecting the signal lines to the Arduino Uno. Immediately above me is a schematic, and we'll go through that a little bit in detail so that you can see what's involved in actually wiring one up for yourself. So the chip itself is 8 pins. Pin 1 is the chip select pin. It is the pin that will enable or disable the RAM chip from operation. It is low true, so when that chip select line is low, the RAM chip will operate. We can transfer data to and from it. When it's high, it will not transfer data, it will just retain what's already there. It is the chip select line that is connected to pin 10, in this case, of the Arduino Uno. Pin 10 is just a digital output pin that we will bring low when we want to read or write, and we will leave it high when we want to deactivate the chip. The second pin on the RAM chip is the serial out. That is the pin on the chip that will transmit the data out of the chip and to the Arduino Uno through the Uno's MISO signal line on pin 12. MISO stands for Master In, Slave Out on the serial peripheral interface. The third pin that's of interest to us is pin 6 on the RAM chip. It is the serial clock that synchronizes the data transfer to and from the serial RAM chip. It is pin 6 on the RAM chip, and it is also connected to pin 13 on the Arduino Uno. Now the last signal pin that we're going to talk about is the pin 5 of the RAM chip, which is the serial data in, or SI, on the RAM. It's connected to the MOSI signal on the Arduino Uno, which is pin 11. MOSI is master out, slave in. So remember that for the serial peripheral interface on the Uno, pins 11, 12, and 13 are the ones that are dedicated to the serial peripheral interface, and any other digital output pin can be used for the chip select. So in this case, we've wired it to pin 10. So the other pins, the pin 7 on the RAM chip and pin 3 on the RAM chip, are two signal lines we're not using. The pin 7 is a hold pin that will allow us to just stop data transfer exactly where it is, which we're not going to use. And then the other pin, NU, is not used. But these pins need to be held high so that they don't inadvertently go low and turn the system off. So what we will do is pull them high through two 10K pull-up resistors, and that will solve that problem. The last pull-up resistor that you can see is connected to the chip select line, and even though the chip select is connected to a digital output on the Uno, there are times when an inadvertent high can happen, or inadvertent low can happen, and turn the chip on when we don't want it to. So that's discussed in the document that we link to in the description below, and you can read it for yourself and see exactly in detail how the chip works. So that's the hardware. Now let's discuss the software. Here you can see we've got a standard Arduino program in the Arduino IDE. A copy of this program is linked in the description below so that you can download it at home and run it yourself. But we'll go through it quickly and see what the program does. There's some functions that actually communicate to the chip that I won't go into too much detail here. It is discussed in a document that is linked to in the description below. So here's the program. At top, of course, we have some comments to tell you exactly what's going on. The first thing we do is have to include the serial peripheral interface library so we can communicate with the chip. And then we have a series of named constants that we define so that it's easier for us to communicate or with the program or to remember what we're doing in the program. They're basically just names that are more meaningful for us than the numbers would be. We have a read mode register and a write mode register that we will write numbers to in those functions that will set the program to either read or write. And then, of course, we've got a reset. We've got read and write commands, and actually to retrieve the data or to write the data. And then we've got two modes that we will talk about today. One is a byte mode where we will write an individual byte at a time. And then the other one is a sequential mode where we will use a burst mode to write a series of bytes at one time to make it a little bit more efficient to communicate to the RAM chip itself. Now, this section is not required for normal Arduino programs, but I've included it here for clarity, and it's more or less standard in other C compilers where you need to define things before you actually use them. These are the 5 functions that are defined in this program to make it easy for us to communicate to the RAM chip itself. The first function, called set mode, will select either between the single byte mode or the sequential byte mode for us to communicate the information that we need in our program. The next 4 functions are the functions that we will use to read and write the data to the RAM chip itself, either in a read byte or a read array, or write byte, or write array mode. So you'll see how this all goes together here in the program shortly. The next thing, we need to create a little bit of data for us to use for the demonstration purposes. I've got two arrays defined. The first array is an array called X, and it basically just has the first 20 characters of the alphabet in it to use as data to write to the memory chip. We have an empty 20-character array that is called read data, and that's there to receive information in a sequential mode that we read from the RAM chip itself. And then I've got a counter for a loop that we will be using in the next part of the program. Now, for this demonstration, we'll just use functions in the setup portion of the Arduino shell program. We will not be using the loop portion in this. We're just going to do things once and then end our program. All right, so what do we do in the setup portion? The first thing we have to do is to create a variable to hold an address to which we will either write data to the RAM chip or read data from. Now, this address is a 32-bit variable. It has to be 32 bits because the address itself is actually 17 bits long. Now, 17 bits is 2 bytes and 1 extra bit. But since we don't have a 3-byte variable in C language, we'll have to go to a 4-byte variable and use the least significant 17 bits of that for our address. Now, the functions know that and will transmit to the chip itself the required part of that data to set up the address. So we've got a 32-bit address. We'll be using that. Every time we want to read or write something, we have to tell it where to get that from, and that's what that's all about. I've got 2 variables here, value and data, that will either hold data to transmit to the chip or to receive the information coming from the chip. And then we have to turn on our chip select, which we already talked about. It's pin 10 of the Arduino Uno. We set it up as a digital output, and we use the named variable CS to do that. The next 2 things are basically for us to, the serial peripheral, or the serial begin will turn on the monitor for us to see what's going on, and the SPI begin will set up the serial peripheral interface for us to communicate to the chip. So now we've got everything set up, ready to go. Let's do 4 things in this program. We will write 5 bytes to memory, 1 byte at a time, and then immediately read those back. And then the next 2 parts of the program, we will write a complete array at one time to memory and then read it right back. So we're going to do those 4 things, and then we'll see how both of the modes work. So the first thing, we'll print a prompt to the serial monitor so that we know where we are in the program, and it says writing data bytes individually. So this will write an individual byte to a specific address each time that we call it. All right, so the first thing we have to do is make sure that the mode of the chip is set so that it will receive 1 byte at a time or transmit 1 byte at a time. So we call our set mode function that does that for us, and we tell it to set it to byte mode. So once that's done, the chip is all set up for us to do it. We can now start to write data to it 1 byte at a time. Now, the basic process to writing anything to this chip, for example, let's talk about the bytes. If you want to write a byte to the chip, you will take the chip select line low to enable the chip so that it listens to us. Then we send it an address. Then after we send it the address, we send it the byte of data, and then we take the chip select high. Now that takes care of writing a byte to the memory chip. If we want to read it, it's the same thing. We take the chip select low to enable the chip. We then tell it we want to read. We send it the address. We then get the information back, and then we take the chip select high again to turn it off. So those are the 2 things, reading and writing, that we will be doing. So here's the writing part of it. We take data. I'm going to initialize the data to 0. And then we will use a for loop to write the 5 bytes of data. Now I'm going to use the for loop counter as the address. So when we enter the for loop, we start with a loop counter of 0. We then go to address 0 in the memory chip, and we tell it to write at address 0 data, which is currently 0. Okay, so at memory address 0, it writes a 0. Then we increment data by 2, so now its value is 2. The program increments I, the loop counter, to 1, so we set our address now to 1, and then we tell it to write at address 1 the data, which is now 2. And then we continue that process until all 5 bytes of data are written to the memory chip. So after that's done, the next thing we do is immediately read back what we wrote. So here's reading each device or each data byte individually. That will be a prompt that shows up on the serial monitor. And then we do the same process. We set the mode to byte mode just to make sure that it's set for us. And then we enter into a loop using the loop counter as the address that we want to read the data from. And then we call the read byte function and we give it an address. The read byte function will then tell the chip to go to that address, which in the first iteration of the loop is 0, and it will return the value that's stored there and put it in the variable called value. And then we just print that value out on the serial monitor so that we can see what's going on. And we continue in that loop doing all 5 of those values, which should be 0, 2, 4, 6, 8, and 10. Now, the next part of the program is where we begin to transmit data sequentially in burst mode so that we can write a complete array at a time. So the first thing we do is we print a prompt to the screen, the serial monitor, to tell us where we are in the program. Then we set the byte mode to sequential so that the RAM chip now knows that we're going to be sending a starting address followed by a series of bytes. And then we call the function write array. Now the write array function requires 3 pieces of information in order to do its job. It needs a starting address in memory where we want to start writing the array. We need the name of the array that we want to transfer to memory, and we need to tell it how big the array is, how many bytes of data we want to send. That's all we have to include. In our case, we send it memory address 0 because we want to start at memory address 0. Send it the array named X because that's got the first 20 characters of the alphabet in it. And then we will send it 20 because that is the size of the array, the number of characters that are contained in it. So that will then take that full array, write it to memory, and we will then immediately read it back from memory so we can see that what we did actually worked. So in order to keep our place in the program, we print a prompt to the serial monitor telling us where we are. Then to be sure that we're set properly, we set the mode to sequential so that it now knows for sure that it's going to be sending a lot of bytes at a time. And then we make one function call to read array. Now read array needs 3 pieces of information also, just like write array. First of all, it needs an address in RAM memory to start reading the information from. In our case, it's 0. That's where we wrote the array called X before. Then we need to have the name of an array in our program, which is going to receive the data transmitted back from the memory chip. And then we need to tell it how many bytes of memory we want to read back. In this case, it's 20 to match the size of the array X that we wrote before. Now, reading the array from memory doesn't tell us anything for sure. It puts the program or the information in our program, but in order for us to see it, we need to get into a loop and use the serial print function for us to get the data from that array and display it in the serial monitor for us to actually see that it happened. All right, so the remainder of the program is the loop part of the program, which we're not using, so that's just an empty loop. And then the following are the complete programs of the functions that we use in order to interface with the memory chip itself. You can see that we've got the set mode function defined first. It's only 4 lines or 4 commands long, but it will set the mode for us on the chip. And then we've got the read byte function, followed by the write byte function. Then we have the read array or write array function, and then the read array function defined in the program. So for brevity's sake, to keep this video a little bit shorter, I won't discuss these in detail. They are described in detail in the document that we've got a link to in the description below. So you can download that and read it to fully understand what's going on. All right, so that's our program. To demonstrate the program, I've already loaded it into the Arduino and brought up the monitor. It's already run, but to demonstrate how it works, I'm going to recompile and load it, and then look at what's on the output of the monitor. So here we're compiling and loading. You can see at the bottom here what's going on, and now the program is run. So to make our linkages to the program, you can see that the very first prompt, writing data bytes individually, was printed there. That's this part of the program where we went through the for loop to write 5 bytes of data, and then we read the data immediately right back in this part of the program, which is this prompt right there. Now, when we read the data back using the for loop, we read and printed this data, which is 0, 2, 4, 6, 8, and 10, which is the loop counter incremented by 2 each time. So the next part of the program, where we write an array, you can see that the prompt is writing an array sequentially, which we do right here. It is the one function call. It writes the array, and it does not write anything to the serial monitor. But we do that in the next part of the program, where we read the array from memory, and then we print it with a loop to the serial monitor, which is right here. So that is the functioning program. You can see how to read and write data to the memory chip in either mode that you need to do for your program. So with a little bit of wiring, an 8-pin chip, and some programming, you can now significantly increase the memory capacity of your Arduino Uno.